What is the most profound secret the universe is keeping from us? For millennia, we have tilted our heads back, gazing into the velvet blackness, feeling the pull of that infinite question. The night sky has been our map, our calendar, our canvas for gods and monsters. It was the backdrop to our earliest stories and the destination of our most audacious dreams. Each point of light a whispered promise of other worlds, other suns, other possibilities. That twinkling canopy was once the exclusive domain of priests and kings, its secrets passed through ritual and prophecy. Later it yielded its truths to the patient eyes of astronomers huddled in the cold of their observatories, meticulously charting the silent gravitational dance of the cosmos. Their discoveries trickled down, reshaping our understanding of our place in the all-encompassing darkness. But in our time, something unprecedented has occurred. That hallowed distant realm has been brought down to Earth, delivered into the hands of anyone with a curious heart and an internet connection. The Grand Observatory, once a mountaintop sanctuary for the few, has become a glowing screen in the palm of your hand. We live in an age of democratized discovery, a time when the universe has been rendered into a digital tapestry accessible to billions. You no longer need a colossal telescope to wander through the stellar nurseries of Orion or to trace the ghostly arms of the Andromeda Galaxy. You just need to open a window. A digital window, and for millions that window is named Google Sky. It is more than a mere application. It represents a fundamental shift in our relationship with the cosmos. A promise of transparency, an open invitation to explore the final frontier from the comfort of your home. This is the celestial atlas of the modern age, a staggering mosaic stitched together from the most advanced eyes humanity has ever built. It compiles and collates petabytes of data from legendary instruments like the Hubble Space Telescope, the Sloan Digital Sky Survey, and the Palomar Observatory Sky Survey. Every pixel is a testament to human ingenuity, a tiny fragment of a celestial reality captured across decades of tireless observation. Google Sky presents itself as an unvarnished truth, a direct feed from the universe to you. When you zoom in on a distant nebula, you trust you are seeing what Hubble saw. When you pan across the river of the Milky Way, you believe you are witnessing a faithful representation of our galactic home. It is our shared public record of everything out there. We have placed our faith in this digital portal, assuming its neutrality depending upon its integrity. We scroll and zoom effortlessly, traversing light years secure in the belief that the map we are holding is an honest one. We were told the age of secrets was over, that the sky belonged to everyone now. We were wrong. This story, our journey, begins not with the familiar constellations of our own celestial backyard, but with a traveller from an impossibly distant shore, a ghost from another star system. For most of human history, the idea of witnessing an object from another solar system was pure science fiction. Our sun's gravitational kingdom was all we knew, a closed family of planets, asteroids and comets, all born from the same spinning cloud of gas and dust. Everything beyond that was unreachable, unknowable. Then in 2017, the silence was broken. A strange cigar-shaped anomaly named Oumuamua tumbled through our system, a cosmic enigma that defied easy classification and sparked a firestorm of debate. 2 years later, it was followed by the comet 2I, Borisov, a more familiar yet no less extraordinary visitor from the interstellar void. These objects were more than mere astronomical curiosities. They were artifacts. They were physical pieces of another star's legacy sent on a journey of millions of years, carrying with them the chemical secrets of their alien birthplace. They proved that the gulfs between stars were not empty, but were instead traversed by silent pilgrims. The astronomical community was electrified. A new field of study was born overnight. Every observatory on the planet was placed on high alert, scanning the darkness, hungry for the next messenger. And then it came. Discovered by the vigilant eyes of the Asteroid Terrestrial Impact Last Alert System, a robotic survey program designed to warn us of incoming threats, it was designated 3I, Atlas, the third interstellar object ever detected. But this one was different. Its trajectory was unusual, its approach unlike its predecessors. Preliminary observations were scant, clouded with uncertainty. It wasn't bright and obvious like a comet, nor was its path as clearly defined as an asteroid. It was faint, elusive. a whisper from the dark. Excitement reached a fever pitch. This was a scientific treasure of immeasurable value. Every major telescope in the world, from the mountaintops of Chile to the orbital platforms above Earth, swiveled in unison, training their sophisticated sensors on the precise coordinates where this celestial phantom was predicted to be. The race was on to decipher its nature before it vanished back into the interstellar night, its secrets intact. And as the professionals worked millions of us, the citizen explorers of the digital age turned to our own trusted portal. We opened Google Sky. We typed in the coordinates, eager to see the raw images to witness for ourselves this new piece of the cosmic puzzle, this emissary from a distant sun. We wanted to see what the telescopes were seeing. We wanted to be part of the discovery, but we saw nothing. Or rather, we saw something far more disturbing than nothing. Right there at the exact celestial address where 3I, Atlas, was supposed to be was a blur, a smudge. It wasn't the familiar black square of a missing data tile, a common artifact in such a vast mosaic. It wasn't a pixelated smear from a corrupted image file. This was something else. It looked deliberate. It was a perfectly rectangular, opaque block of digital redaction carefully placed with unnerving precision. A digital thumb pressed firmly against the eye of the telescope, saying, "You are not allowed to see this." The initial reaction was simple confusion. A glitch, surely. A server error. Someone somewhere would fix it soon. Online forums began to buzz with questions. People checked and rechecked the coordinates, refreshed their screens, cleared their caches. Yet the blur remained. It was static, immovable, a permanent feature of this patch of sky. Then a deeper, more chilling analysis began. Data analysts and amateur astronomers started to plot the exact trajectory of 3I, Atlas, a moving target, against the static background of the starfield. They discovered the truly impossible nature of what they were seeing. The blur wasn't just in the general vicinity. It was positioned with mathematical perfection, covering not just where 3I, Atlas, was at one moment in time, but masking a significant portion of its predicted path across the sky. The probability of a random data error, a simple technical glitch occurring with such specific targeted placement, was infinitesimal. It was statistically inconceivable. It was like finding a single perfectly redacted word in a library of 1 billion books, and that word just happens to be the one you were looking for. The soft murmur of confusion in the online communities began to harden into a chorus of suspicion. This didn't feel like an accident. This felt like an act. Someone had intentionally reached into our shared window on the universe and pulled down a shade. They had censored a starfield. The implications were staggering, sending a shockwave through the communities of people who had put their faith in the open-source nature of modern astronomy. The promise of a democratized cosmos, of transparent and accessible data for all, was shattered by a single, inexplicable black box. The question, the one that now hangs over this entire affair, is terrifyingly simple. Why? What could possibly be traveling through the dark between stars that would warrant an act of cosmic censorship on a global scale? We are left with two diverging paths, two potential realities, each more unsettling than the last. The first path is that of mundane error, a sophisticated, multi-layered, and frankly unbelievable coincidence. This theory suggests that a series of unrelated technical failures happen to align perfectly. A damaged sensor on a key telescope, a flaw in the image processing software, a data transmission error, and a bug in the Google Sky aggregation algorithm, all conspiring together to create a blur that just so happened to perfectly eclipse the arrival of the most anticipated interstellar object in history. It is a plausible, rational explanation, the kind that soothes the mind by avoiding the abyss of conspiracy. It requires us to believe in a cascade of improbable accidents, a lightning strike of bad luck. It allows us to maintain our faith in the systems we trust, to believe that the map is still for the most part honest. It is the easy answer, but it is an answer that for many strains credulity to its breaking point, because then there is the second path, the darker path, the one that leads to a far more profound and disturbing conclusion. This path suggests that the blur is not an error at all, that it is in fact a message, a deliberate act of concealment, This theory posits that someone, some agency with access to the core infrastructure of our global astronomical data streams saw something in the initial observations of 3I, Atlas, something they did not want us to see. Something so world-altering, so potentially disruptive, that they took the unprecedented step of altering the public record of the sky itself. They censored reality. This conclusion forces us to ask a cascade of chilling new questions. Who possesses such power? Who are they? A clandestine government program? A secretive multinational corporation? A global consortium operating in the shadows? And the ultimate question, the one that sits at the very heart of this mystery, what is 3I Atlas? What is it really? Is it just a rock, a chunk of alien ice? Or is it something more, something that doesn't conform to our understanding of the universe, something unnatural, something that had to be hidden? The existence of this blur transforms a simple scientific observation into a potential conspiracy of cosmic proportions. It turns a journey of discovery into an investigation. We are no longer just looking at a visitor from another star. We are now staring at the shadow it casts, at the veil that has been violently drawn over it. Our quest is no longer simply to understand what 3I Atlas is. Our quest now is to understand why we are being forbidden from seeing it. We must peel back the layers of this digital redaction. We must drill down through the code, interrogate the data, and hunt for the digital breadcrumbs that could lead us to the truth. Because somewhere beneath that inexplicable blur lies a secret deemed so important, so powerful, that someone was willing to break our window to the universe to keep it, and we are going to find out what it is. Undefined. What if the universe has been sending us messages all along? Not in language, not in mathematics, but sealed inside cosmic bottles cast adrift from distant shores of fire and ice, traversing the unimaginable void for millions of years. We've always imagined these messages would arrive as a signal, a deliberate pulse in the radio silence. We never expected them to be physical objects, ancient relics from other solar systems tumbling silently past our front door. For most of human history, the idea was pure fantasy, the stuff of speculation whispered around campfires and later in the hallowed halls of science. We believed, gravitationally isolated our solar system, a self-contained island in an endless ocean of stars. Any visitor we saw, every comet, every asteroid was one of our own, a local traveller bound by the sun's immense gravitational leash, destined to return again and again in a predictable cosmic dance. They were family familiar faces in the night, but the universe is more complex, more chaotic, and infinitely more interesting than our simple models once allowed. We were about to discover that our island was not so isolated after all, and that the ocean was indeed sending its driftwood to our shores. The first hint, the first cryptic postcard from afar, arrived in 2017. It was given the Hawaiian name Oumuamua, meaning a messenger from afar arriving first. The name was poetry, but the object itself was a scientific paradox. It was small, dark, and spinning in a way we had never witnessed. Its shape, inferred from the bizarre fluctuations in its reflected light, was utterly alien. A long, slender shard, perhaps 10 times longer than it was wide, like a cosmic needle threading its way through our system. No comet we had ever seen looked like this. No asteroid behaved like this. But its most profound secret was written in the geometry of its path. It was not in orbit. It was not bound to our Sunday. Oumuamua was moving too fast, its trajectory a searing, open-ended curve known as a hyperbola. This was no local traveller. It was a tourist on a one-way ticket, an interloper from interstellar space, the first confirmed object of its kind ever detected. And then, as astronomers tracked it with every telescope powerful enough to catch its faint, fading light, it did something impossible. It sped up. As it moved away from the sun, it gently but undeniably accelerated, pushed by a force that wasn't gravity. Comets do this, of course, as solar heating vaporizes their ice, creating jets that act like tiny rocket thrusters. But Oumuamua had no tail, no fuzzy coma of gas and dust. It was venting something, or it was being pushed by something. The mystery was so deep, the data so strange, that it prompted serious, if controversial, speculation. Was this a natural object of a kind we simply couldn't comprehend? Or was it something else, a piece of technology, a solar sail from a long-dead civilization, we had no answers. Oumuamua was already gone, hurtling back into the darkness, leaving a trail of profound and unsettling questions in its wake. It had opened the door, proving that interstellar visitors were not just possible, they were real. And we, a species newly awakened to this reality, began to watch the skies with a new kind of anticipation. We were waiting for the next one. We didn't have to wait long. Just 2 years later, in the final days of 2019, it happened again. This time, the discovery wasn't made by a single observatory on a Hawaiian mountaintop, but by a sleepless, automated network of them. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, is our planet's sentinel. 2 telescopes, one in Hawaii, one in Chile, scan the entire visible sky every few nights, a robotic, tireless vigil against incoming threats. Their purpose is pragmatic: to find any asteroid on a collision course with Earth while we still have time to react. They produce a torrent of data, a nightly flood of digital images that are sifted by sophisticated algorithms, all searching for one thing: a faint pinprick of light that is moving against the static backdrop of the stars. On December 28th, the algorithm flagged one such object. It was impossibly faint, a barely there ghost on the photographic plate, designated initially with the unpoetic name A10BMLZ. To the software, it was just another data point, another potential near-Earth object to be catalogued and tracked. But as observatories around the world were alerted and began to follow up, a very different story began to emerge. With each new observation, with every refinement of its position, the object's trajectory became clearer, and with that clarity came a jolt of collective global excitement. The orbital calculations were undeniable. Just like Oumuamua, this new visitor was on a hyperbolic path. It was another traveler from the void, another emissary from an unknown star. The third interstellar object ever found. It was officially named 3I, Atlas, the I for interstellar. This time, however, things were different. Oumuamua was a mystery we barely had time to glimpse as it shot past us. It was small, inert, and already heading out of the system when we found it. 3I, Atlas, was a completely different beast. It was discovered on its way times in times, giving us months, perhaps years, to study it. And more importantly, it was not a passive shard of rock. As it drew closer to the sun, something spectacular began to happen. The faint stellar point of light began to transform. It grew a halo, a soft, ethereal shroud of gas and dust. It unfurled a tail, a delicate streamer of vaporized material pushed back by the solar wind. 3I, Atlas, was not an asteroid, it was a comet, an interstellar comet. This was a monumental discovery. A rock like Oumuamua tells you about the dynamics of other solar systems, but a comet is a time capsule. Locked within its ice are the primordial ingredients of its birthplace. Water, carbon monoxide, ammonia, organic molecules, the very building blocks of planets, and perhaps of life itself, preserved in a deep freeze for billions of years. Suddenly we had a sample, a messenger that was not just passing through but was actively sublimating, releasing its ancient secrets into space right before our eyes. It was as if the cosmic bottle had uncorked itself. Every spectroscope on Earth and in orbit turned to stare. The data poured in. This was our first chance to perform a chemical analysis, a direct tasting of the material from another star's protoplanetary disk. The significance cannot be overstated. Was the chemistry of its home system similar to ours? Did it contain the same ratios of life-giving elements? Finding out could tell us whether the recipe for our solar system is a common one throughout the galaxy or a cosmic anomaly. The excitement in the astronomical community was palpable. This wasn't just an object of curiosity, it was a Rosetta Stone from the stars. Then, in early February of 2023, Atlas, did something even more dramatic. It underwent a violent outburst. In a matter of days, it brightened by a factor of several hundred. A celestial blowtorch had been lit deep within its nucleus, causing a geyser of gas and dust to erupt into space, vastly expanding its coma and making it an even juicier target for observation. What caused it is still debated. Perhaps a pocket of supervolatile ice, like frozen carbon monoxide, was suddenly exposed to sunlight, flashing into gas with explosive force. Or maybe the comet itself, weakened by the unfamiliar thermal stresses of our sun, had begun to break apart, exposing vast new tracts of fresh ice to the solar rays. Whatever the cause, the effect was profound. 3i, Atlas, was putting on a show. It was a dynamic, evolving, and breathtakingly informative object. Professional astronomers scrambled for telescope time, writing urgent proposals, retasking multi-million-dollar observatories to stare at this one fleeting point of light. The messenger was not just speaking, it was shouting. And for a world on the cusp of a global pandemic, the story of this visitor from another star system was a welcome and inspiring distraction, a reminder of a vast, mysterious universe that operates on scales far beyond our terrestrial concerns. It was a story that belonged to everyone, and in the 21st century there is one place, one universal tool that allows anyone with an internet connection to participate in such a discovery, to see the universe not through an artist's rendering but through the real data. It is our shared celestial atlas, the great equalizer of astronomical access, Google Sky. It isn't a telescope in itself, but something far more ambitious. It is a mosaic, a seamless digital tapestry woven from the data of the world's greatest astronomical surveys. The Sloan Digital Sky Survey, the Palomar Observatory Sky Survey, images from the Hubble Space Telescope, trillions of pixels of raw scientific data are stitched together, creating a virtual universe on your screen. You can zoom from a panoramic view of the Milky Way right down to a faint distant galaxy, knowing that what you are seeing is for the most part an authentic representation of the sky. For professional scientists, it's a quick-look tool. For educators, it's an invaluable teaching aid. But for millions of amateur astronomers and curious members of the public, it is their primary window into the cosmos. It represents a promise of transparency, a democratization of the heavens. It is the public record. In the weeks following the discovery and outburst of 3i, Atlas, this digital window became more important than ever. While the professionals captured high-resolution spectra and detailed images, amateurs across the globe turned to Google Sky. They wanted to see it for themselves. They would input the comet's official celestial coordinates, its right ascension and declination, into the search bar, and the program would dutifully slew its virtual view across the simulated star field to the precise location of this extraordinary visitor. They could track its path day by day as it journeyed inward toward the Sunday. For a time, it worked perfectly. The comet appeared as it should, a faint smudge against the black, its position matching the predictions published by the Minor Planet Center, the official clearinghouse for all such data. It was science in action, open and accessible. The first person to notice something was wrong wasn't a professional astronomer in a high-tech control room. It was likely a student in their dorm or an enthusiast in their suburban home office, probably late at night. The discovery didn't come with a eureka moment, but with a flicker of simple, mundane confusion. A user, let's call her Sarah, a longtime member of an online astronomy forum, types in the latest coordinates for 3i, Atlas, expecting to see the now familiar fuzzy patch of light. The virtual telescope on her screen pans across the starfield, but when it stops, something is off. Where the comet should be, the image is strange. It's not an error message. It's not a black void. It's a blur. A coarse rectangular smudge, as if someone had taken a digital eraser to that tiny patch of the universe. The stars around the area are sharp, crystal clear points of light, but the exact location of the interstellar comet, a box several arc-minutes across, is an opaque, pixelated mess. Her first reaction is dismissal. It must be a glitch, a server error, a problem with her internet connection, a temporary artifact from the imaging pipeline that stitches the sky together. She refreshes the page. The blur remains. She clears her cache, restarts her browser. Still there, a prickle of unease begins to form. This doesn't look like a random glitch. A random glitch is chaotic. This looked deliberate. It looked precise. It was a perfect rectangle oriented exactly with the grid of the sky, and it was masking the one object that had captured the world's attention. She takes a screenshot. With a few hesitant keystrokes, she uploads it to the forum. The post is simple, uncertain. Anyone else seeing this, trying to look up 3i, Atlas on Google Sky and getting this weird block. Is the data corrupted? Within minutes, the replies start to trickle in. The trickle becomes a flood. Confirmed. Seeing it here in the UK. Same in California. What is that? I checked the coordinates from yesterday's ephemeris. The blur is moving. It's following the comet's predicted path. That last comment hangs in the digital air charged with significance. This was not a static flaw in the base imagery of the sky survey. This was not a dead pixel on a forgotten photographic plate from years ago. This was an active dynamic anomaly. An opaque box was being systematically drawn over the precise location of a moving object, updated daily, as if to deliberately and meticulously hide it from public view. The tone of the online conversation began to shift. Initial confusion curdled into suspicion. Curiosity morphed into concern. The questions started flying faster and more pointed. Why would anyone do this? Google Sky is built from public and academic survey data. Who has the authority to alter it? And why this object? Why the most scientifically fascinating interstellar visitor we have ever encountered? On a platform designed for transparency, a deliberate and targeted act of censorship seemed not just improbable, but impossible. Yet the evidence was right there on thousands of screens around the world. A deliberate wound in the data, a curtain drawn across the cosmos. The public record had been altered and nobody knew why. The mystery of 3I, Atlas, was no longer just about its distant origins. It was now about what someone, somewhere was trying so desperately to conceal. And so the signal fire was lit, not with flame but with photons and pixels, a single point of bewildered inquiry sparking a blaze across the global network. What had begun as one person's late-night curiosity, a nagging anomaly in the celestial atlas on their screen, now spiraled into a collective obsession. The coordinates of the 3I, Atlas blur, became a destination, a digital pilgrimage site for thousands, then tens of thousands of inquisitive minds. In this new, sprawling territory of digital astronomy, the armchair explorer was suddenly deputized, becoming a frontline investigator in a mystery that felt both impossibly vast and deeply personal. Within hours, the digital town squares of the internet, the forums, the subreddits, the newly spawned Discord servers roared to life. It was a cacophony of digital voices, a chaotic but brilliant symphony of collaborative thought. Programmers from Silicon Valley debated with amateur astronomers in rural Japan. Physics students in Germany cross-referenced notes with retired engineers in Brazil. They were a decentralized, self-organizing detective agency, united by a single glaring piece of anti-evidence, a hole in the sky where something ought to be. Their first task was simple, born of a disciplined skepticism that is the hallmark of true scientific inquiry. They had to try and break it. They had to prove it was a mistake. The initial wave of explanations came swiftly rolling in with the predictable tide of online discourse. These weren't whispers of conspiracy yet, but the calm, reasonable-sounding dismissals of seasoned internet commentators and a few beleaguered-sounding official sources. The most prominent theory and the most plausible was that of a simple image stitching error. You have to remember that Google Sky isn't a single photograph. It's a mosaic, a colossal quilt stitched together from countless individual images taken by numerous surveys over many years. A digital tapestry woven from the threads of the Sloan Digital Sky Survey, the Palomar Observatory Sky Survey, and data from Hubble itself. Sometimes the automated algorithms that perform this titanic task of quilting the cosmos together simply drop a stitch. The seams can be messy. You might get overlapping data, mismatched exposures, or in rare cases, a block of pure corrupted data that renders as a void. It was a clean, technically sound explanation. It suggested the blur wasn't a redaction of something that was there, but a failure to render it in the first place. This was the digital equivalent of a patch of bad plaster on a ceiling fresco, an unfortunate but ultimately meaningless flaw in the artistry of the code. It was the explanation that required the least amount of imagination and invited everyone to simply move on. Close behind this theory came the idea of a bad pixel cluster, or a charge-coupled device, a CCD artifact. In this scenario, the fault lay not with Google's software, but with the hardware of the telescope that captured the original plate. A sensor on a multi-million-dollar instrument bombarded by cosmic rays or suffering a minor electronic failure could produce a dead zone in its field of vision. This flawed image, once fed into the massive Google database, would then be perpetuated indefinitely, a ghost in the machine born of a single fried transistor miles above the Earth. It was an even more benign explanation, blaming the quiet fallibility of mechanics rather than any conscious decision. It was simple, elegant, and entirely dismissible. And then there were the catch-all explanations, the intellectual shrugs offered to placate the growing noise. Perhaps it was atmospheric distortion from a ground-based telescope, a satellite streak that was poorly processed, or some other form of data corruption so esoteric it wasn't worth the effort to diagnose. The initial official response when it came at all was a version of this. A few terse emails from public relations departments and vaguely worded forum posts from affiliated scientists suggested that this was a known type of graphical glitch, a minor bug in a sea of petabytes, and that engineers were looking into it. For a day or two, this seemed to satisfy the mainstream. The mystery was defanged, reclassified from a potential cosmic secret to a mundane IT support ticket. But the digital detectives huddled in their online enclaves were not satisfied. They treated these plausible dismissals not as conclusions, but as hypotheses to be tested to destruction. And with the rigor of a peer-reviewed study, they began to systematically, meticulously tear them apart. The stitching error theory was the first to fall. The citizen scientists, now organizing into dedicated teams, began a forensic examination of the blur's perimeter. If it were a seam between two different image plates, its edges should align with the known boundaries of the survey images. They wrote scripts to overlay the grid lines from the original sky surveys onto Google's map. The result was damning. The blur, a near-perfect rectangle, did not correspond to any known image seam. It sat defiantly in the middle of a pristine high-resolution plate from the Palomar survey. Its borders were too sharp, its corners too precise. Stitching errors are messy like torn fabric. They feather out, they show distortion, they betray the chaotic nature of their creation. This, by contrast, was an act of digital surgery. It was a clean excision, a shape so geometrically perfect it screamed of intent. It wasn't a dropped stitch in the cosmic quilt. It was a patch deliberately sewn over it, a piece of black velvet hiding the tapestry beneath. The next pillar of plausible deniability to crumble was the artifact theory, the ghost in the machine. This was a more difficult proposition to disprove as it required going back to the source. But the community was resourceful. They weren't just looking at Google's final product. They began a process of digital archaeology, digging down through the layers of data aggregation. They located the raw, unprocessed photographic plates from the original Palomar Observatory sky survey, the very images Google had used to build that section of its map. They found them in dusty university archives and public access scientific databases. And when they pulled up the original source data for those exact coordinates, their collective breath caught. There was no blur, there was no dead pixel cluster, there was no artifact. On the original unprocessed foundational data, the star field was perfect. It was a pristine, uninterrupted vista of distant suns and galaxies exactly as it should be. The stars that Google Sky had erased were shining brightly on the source photograph, their light captured decades ago silent witnesses to their own digital execution. The implication was staggering, and it sent a shockwave through the community. The flaw wasn't in the original eye on the sky. It was in the brain that processed the vision. The corruption was not in the data, it was in the presentation of the data. It was like discovering an ancient untouched manuscript, only to find that the publicly available digital copy has a paragraph neatly blacked out with a digital marker. The act of obfuscation was no longer a possibility. It was the only remaining explanation. With the two most rational explanations lying in ruins, the community turned its full, unblinking attention to the blur itself. They subjected it to a level of scrutiny that would make a counterintelligence agency proud. They ran spectral analyses on the pixels. It wasn't true black, a simple absence of data. It was a flat, uniform color and inserted value RGB 000, which is fundamentally different from a null data point. They magnified it to its limits, searching for any compression artifacts or digital watermarks that might betray its origin. They found none. It was a void of terrifying, featureless perfection. Then came the most crucial phase of the investigation, the temporal analysis. Google Sky, like its terrestrial counterpart, is not a static image. Its data is updated periodically as new surveys are conducted or old data is reprocessed. Using archival web services and cached data, members of the community began to painstakingly reconstruct a timeline of that specific sector of the sky. They became time travelers, flicking back and forth through different versions of Google's digital universe. For years, up until the early months of that very year, the coordinates were clear. The stars were there. The field was immaculate. They cross-referenced this timeline with the orbital path of 3I, Atlas. The result was a final, incontrovertible piece of evidence. The black rectangle had not been there for years, a latent bug waiting to be discovered. It had appeared in a specific data refresh, a single update that went live approximately 3 weeks times after times 3. Atlas, had passed through that exact location on its mysterious sunward trajectory. The timing was too exquisite, too perfect to be a coincidence. It was a direct digital reaction to a physical event. Something had passed through this region of space, and in its wake, the map itself had been censored, the historical record altered. The mood within the online communities shifted irrevocably. The initial playful spirit of collaborative puzzle solving curdled into something darker, more urgent. The dismissive shrugs from the outside world no longer felt like rational skepticism but like gaslighting. The silence from official institutions began to feel deafening. Why would anyone do this? A glitch is an accident. An error is a mistake. But this was a conscious act. It was a deliberate, calculated decision made by a person or an algorithm to point a celestial blowtorch at a tiny patch of the sky and burn it from the public record. The questions began to fly sharp and pointed. Who ordered this? What precisely was under that black box? Was it a remnant of the comet's passage? Some unexplainable debris field that defied the laws of physics? Was it evidence of the anomalous encounter that the fringe theorists had whispered about since the comet's discovery? Or was it something else entirely, something that had been there all along, that 3I, Atlas, had merely drawn our attention to? The comet was the key, as one popular post put it, and it had unlocked a door that someone somewhere desperately wanted to slam shut. The citizen scientists, having exhausted their own avenues of investigation, now changed tactics. They were no longer just talking to each other. They began to shout outwards. They compiled their evidence, the failed stitching theory, the pristine source data, the damning timeline, into meticulously documented reports, video essays, and open letters. They began a coordinated campaign not of spam or abuse, but of relentless, polite, and unyielding inquiry. They flooded the inboxes of Google's press relations. They tweeted at the heads of the world's major space agencies. They posted their findings on the official forums of astronomical societies. Their demand was simple and singular: transparency. Release the raw data logs for this sector. Provide the unredacted imagery from the most recent survey updates. Explain the precise technical justification for the insertion of this specific geometric null field at these specific coordinates at this specific time. They weren't demanding to know about aliens or secret government programs. They were simply asking the cartographers of the cosmos to show their work, to explain why a piece of the map had been cut away. The response was a profound and unnerving silence. Google issued no further statements. The scientific institutions, which had once been happy to engage with amateur astronomers, suddenly went quiet on the subject. The forum threads asking the difficult questions were locked by moderators or quietly deleted. The wall of institutional silence was in its own way more alarming than any official denial. It transformed a growing suspicion into a hardened conviction. It suggested that the truth wasn't merely inconvenient or embarrassing, it was dangerous. It confirmed that there was indeed something behind the curtain. And as the silence deepened, the global community of digital detectives braced itself, realizing they had stumbled from a simple graphical anomaly into the shadow of a genuine conspiracy, a secret someone was willing to go to extraordinary lengths to keep. The question was no longer what the blur was, but who was so afraid of us seeing it. The debate had raged in the quiet corners of the internet, a firestorm in a digital teacup. Was this blur, this strange and unsettling void where 3I Atlas should be a simple mistake, a glitch in the matrix of Google's colossal servers, or was it something else, a form of cosmic dust, perhaps a previously unknown nebula, perfectly positioned to obscure our view, one in a trillion celestial coincidence? For weeks, speculation was the only currency we had. But speculation, like currency, can be devalued. It crumbles in the face of hard data, and a new kind of explorer was now entering the fray. They were not astronomers in the traditional sense. Their telescopes were not arrays of glass and steel, but powerful algorithms and forensic software. They were digital archaeologists, ready to excavate the layers of code and compression that formed this controversial patch of sky. Their mission was not to look deeper into space, but deeper into the image itself, to determine if this wound in the data was inflicted by nature or by a human hand. To understand their hunt, you have to understand the fabric of a digital photograph. It isn't a perfect monolithic window. It is a mosaic, a tapestry woven from pixels, each one a tiny container of information about color and brightness. This tapestry has a texture, a grain. It has a history. Every time an image is saved, compressed, or altered, it leaves behind a subtle trace, a digital fingerprint invisible to the naked eye but screamingly obvious to the right software. The researchers, a scattered global team of data scientists and imaging experts communicating through encrypted channels, began their work by treating the blurred region not as an astronomical object, but as a crime scene. Their first tool was a forensic scalpel known as error level analysis, or ELA. This technique doesn't look at the image itself, but at its ghost, the subtle variations in its compression rate. An original untouched photograph should have a relatively uniform level of compression noise across its surface, but a copy-pasted element, a digitally added smudge, will have been compressed a different number of times than its surroundings. It will shout its foreignness. They fed the coordinates of 3I Atlas into their programs, and the results that came back were immediate and chilling. As the analysis rendered the surrounding starfield resolved into a uniform dark grey texture, the expected quiet noise of an authentic image. But the blur itself lit up like a flare. It was a stark incandescent white against the grey, a screaming anomaly in the data stream. It was a digital transplant, an organ rejected by its host body. The compression history was fundamentally, irreconcilably different. It was like finding a single, freshly printed page bound into the heart of a medieval manuscript. The content of the page might be blank, but the paper, the ink, the very molecules of its existence betray its modern origin. This wasn't a glitch. Glitches are random, chaotic. They create artifacts and corrupted data blocks. This was clean. It was precise. It was an act of deliberate digital surgery, and the analysis had just found the scar tissue. But this was only the first cut. The team pushed deeper, employing a battery of other techniques, each one designed to cross-examine the data. They used pixel value histograms to chart the distribution of light and color. In a natural image, even of deep space, these values form a smooth, predictable curve. The blurred region, however, produced a bizarrely artificial graph, a plateau with unnaturally sharp cliffs, where the blurred patch met the real starfield. It was as if a painter had drawn a perfect circle of grey on a canvas of infinite subtle texture. It simply didn't belong. They analysed the chromatic aberration, the tiny colour fringes that optical lenses produce around bright objects. The stars surrounding the void had them the faint, authentic signatures of the telescope that took the picture. The blur had none. It was sterile, flat, devoid of the imperfections that give reality its signature. Each test was another nail in the coffin of coincidence. The blur was not a nebula. It was not a camera flare. It was not a processing error. It was a patch, a cover-up written in the binary language of ones and zeros. The evidence was overwhelming, a mountain of forensic data that pointed to one inescapable conclusion. Someone somewhere had intentionally placed this digital mask over the recorded position of 3I Atlas in Google Sky's database. The revelation sent a shockwave through the small community that had been tracking the anomaly. The question was no longer times what times the blur was, but times who. Times had put it there, and for God's sake, times why. Times. It was a stunning conclusion, but it also opened a frightening new door. Proving the blur was artificial on one platform was one thing. But what if it was a systemic, widespread act of censorship? Was this happening everywhere? Had this tiny, mysterious corner of the cosmos been redacted from all of our maps? The investigation had to expand. It had to go global. The team's focus pivoted from forensic analysis to a grand cross-platform comparison. If this was a conspiracy, its scope was the next mystery to unravel. The digital universe of astronomy is not a monolith. While Google Sky is the most accessible and widely used public portal, it is far from the only one. It draws its information from a multitude of older, more scientifically rigorous surveys. The team began their new search with the European Space Agency, or ESA. Their archives, particularly the ESA Sky application, are a treasure trove of data from world-class observatories and satellites, a more professional, less polished counterpart to Google's public-facing interface. With a palpable sense of tension, one of the researchers in Germany navigated the European portal. They typed in the same right ascension and declination, the precise celestial address that hosted the phantom blur on Google's map. The screen refreshed, the star field loaded, and everyone on the encrypted channel held their breath. There at the exact coordinates against the inky black was nothing. Absolutely nothing. No blur, no smudge, no void. Just a serene, clear, and achingly normal patch of space sprinkled with the faint, distant light of ancient galaxies. The stars shone crisply. The darkness was pure. 3I Atlas itself was not visible in this particular dataset, which was from an earlier epoch, but the key was that its times, location times, was completely, utterly pristine. A collective virtual sigh of relief and astonishment rippled through the team. It was the first major break. The censorship, it seemed, was not universal, but one data point is not a pattern. They had to be certain. The next stop was American. They turned to NASA's Whirlwind, a powerful open-source platform that allows users to layer different astronomical surveys on top of a virtual globe of Earth and sky. They pulled up the data from the Palomar Observatory Sky Survey, or POS, one of the most comprehensive photographic atlases of the northern sky ever created. The images, originally captured on vast glass photographic plates over decades, formed the very backbone of much of Google's own visual data. They zoomed in the crosshairs, narrowing on that now infamous point in the cosmos. Again, the result was the same. The image was clear. The field of view was unobstructed. The star patterns matched perfectly with the surrounding regions, with no hint of tampering, no sign of a digital cataract. It was like visiting the real-world location of a photograph you'd only ever seen with a person crudely photoshopped out of it. The absence of the forgery was more damning than its presence. They kept digging, moving from one database to another, a frantic, globe-spanning audit of humanity's collected portrait of the heavens. They checked the Sloan Digital Sky Survey, a massive multispectral survey that has mapped hundreds of millions of celestial objects. The location was clean. They accessed the archives of the 2-micron all-sky survey, which views the cosmos in infrared light peering through dust clouds that obscure visible light. The location was clean. They even pulled up niche, specialized datasets from observatories in Chile and Hawaii. Again and again, the verdict was unanimous. From the European Southern Observatory to the National Optical Astronomy Observatory, the sky was whole. The map was complete. The celestial record, as far as the professional and academic world was concerned, was untarnished. The blur, the censorship, the lie, it existed in only one place, a single isolated digital island. It was exclusive to the public-facing, commercially owned, universally accessible platform known as Google Sky. The full weight of this discovery began to settle upon the team, a chilling realization that was far more disturbing than the initial mystery. This wasn't a case of a government forcing a coordinated global blackout. That, in a way, would have been more understandable. A state secret is a state secret. This was something different. This was more subtle, more insidious. The professional astronomical community, with its access to the raw primary data, would see nothing amiss. For the scientists, the academics, the people working at the cutting edge of cosmic discovery, the sky remained open. The censorship was not for them. It was for you. It was for us. It was a redaction aimed squarely and exclusively at the general public, at the billions of curious minds who use Google's tools as their primary window into the universe. It was a calculated act of information control, hiding something in plain sight on the world's most popular map, banking on the simple assumption that most people would never know where else to look. The audacity of it was breathtaking. This singular platform-specific nature of the blur transformed the investigation entirely. It was no longer an abstract puzzle about data integrity. It was now a direct confrontation with a corporate entity of unimaginable power and influence. Google's servers don't just host data, they curate our reality. The algorithms that show us search results that recommend videos that map our streets also map our sky. And in one specific place for one specific object, that map had been deliberately falsified. The blur was no longer a curiosity. It was a potential scandal of astronomical proportions. It was evidence of an entity inserting itself between humanity and the cosmos, acting as a gatekeeper to the stars and deciding there was something out there that we, the public, were not meant to see. All the innocent explanations, all the charitable assumptions of error or coincidence had been systematically, forensically, and now comparatively destroyed. They had been replaced by the cold, hard certainty of a deliberate act. The central question, the one that had been a whisper at the start of this journey, now became a thunderous, terrifying roar. What could possibly have been observed at that specific point in space at that particular time that would warrant such a targeted, high-tech and risky act of digital concealment? 3I. Atlas was by all public accounts a simple comet, a chunk of ice and rock on a long looping journey through our solar system. Thousands of such objects are tracked. They pose no threat. They hold, we are told, no great secrets. And yet this one was different. This one had been singled out. This one had been masked, its passing obscured by a digital phantom. The blur, now proven to be an artificial veil, hinted at something extraordinary hidden behind it. It suggested that 3I, Atlas, was not just another traveler in the dark. It was the custodian of a secret. A secret so profound, so important, or perhaps so dangerous, that one of the most powerful corporations on Earth felt compelled to erase it from our view of the heavens. The hunt for the nature of the blur was over. A new hunt, a far more perilous one, was just beginning, the hunt for what it was hiding. The focus of our investigation would now have to shift from the digital to the physical, from the code to the comet itself. We had to understand the object at the heart of the conspiracy. What was 3I Atlas really? And so the glitch became a wall, the anomaly an artifact. What was once a simple patch of digital darkness, an irritating smudge on our window to the universe, was now understood as something far more deliberate, a redaction precise and surgical, a digital curtain drawn across a specific coordinate in the heavens, hiding not just a cluster of pixels but a question that now burned through the astronomical community and spilled into the public consciousness. The evidence pieced together from archived server logs, from the object's ghosted telemetry, from the very unnatural perfection of its erasure, pointed not to a careless error, but to a calculated act of informational containment. The question was no longer what times happened to the image of 3I, Atlas. The question that echoed in the silence it left behind was, why? Why would someone, some agency with immense power, reach into the public domain and pluck a single wandering star from our sky? In the vacuum of official explanation, 1,000 theories rushed in, each more staggering than the last. You see, when the gatekeepers of knowledge lock a door, they don't just create a mystery. They create a mirror reflecting our deepest hopes, our most profound fears, and our unsettling suspicion that we are not being told the whole truth about the universe we inhabit. The first, and perhaps most grounded of these theories, came not from the observatories, but from the hushed, labyrinthine world of intelligence and defense. It was a hypothesis born of terrestrial paranoia, suggesting the phantom in our sky was not from the void between stars, but from the secretive budgets of a world superpower. According to this narrative, 3I, Atlas, was never an interstellar object at all. It was a ghost, a sophisticated piece of electronic camouflage, a designated cover for something far closer to home. Perhaps it was the first test of a new generation of orbital weapon, a hypersonic glide vehicle practicing maneuvers in the exosphere, or a surveillance satellite with capabilities so revolutionary that its very existence had to be denied. A former signals intelligence analyst, speaking under the condition of strict anonymity, framed the logic with chilling clarity. He argued that creating a phantom interstellar event provides the perfect cover. It directs the world's telescopes, both professional and amateur, to a specific patch of sky at a specific time. While astronomers search for a comet that isn't there, the real asset, cloaked and silent, can perform its mission, its electronic emissions and thermal signature lost in the noise of the official search. The subsequent blurring of the object from Google Sky wouldn't be about hiding an alien messenger. It would be about scrubbing the digital breadcrumbs of a black-budget military project, a final act of sweeping up the celestial stage after the secret performance was over. This theory paints a picture of a new Cold War being waged in the silent theater of space, a world where the cosmos itself is weaponized not just with lasers and missiles, but with information and deception. The blur on our screen becomes a symbol of a terrestrial power struggle, a reminder that the heavens above are now a contested domain, a reflection of the conflicts below. It suggests that the greatest secrets might not be what's coming from distant suns, but what's being launched from our own planet in the dead of night. If this were true, the implications are profoundly unsettling. It means that public scientific infrastructure platforms like Google Sky, that we believe are for universal discovery, could be co-opted as tools of statecraft and military misdirection. It transforms our shared quest for cosmic understanding into a potential pawn in a geopolitical game we are not even aware we are watching. The erasure of 3I, Atlas, in this context, is an act of censorship, not to prevent panic or protect a profound discovery, but to maintain a strategic advantage. It's a quiet assertion of dominance, a warning that even the stars can be classified and our view of them can be curated and controlled. The truth in this scenario is not about aliens or cosmic wonders. It's about power. But a second, far more unnerving theory began to circulate, one that accepted 3I, Atlas, as a genuine interstellar visitor, but of a kind so terrifying that ignorance was deemed a public good. What if the object was not a messenger but a harbinger, a carrier of something so dangerous that its discovery would irrevocably shatter our world, not through invasion but through simple proximity? This hypothesis branched into several grim possibilities. One posited that the object's composition was unlike anything known to science. Spectroscopic analysis, perhaps conducted in secret by military-grade sensors before the object was scrubbed, might have revealed elements or molecular structures that defy our understanding of physics. It could have been a fragment of a neutron star, a piece of strange matter, or a naturally occurring object composed of what physicists call exotic matter. Such an object, even a small one, could act as a catastrophic catalyst if it entered our solar system's delicate environment, its properties potentially capable of triggering a chain reaction on a planetary scale. Revealing its existence would be impossible. How do you explain to the public that a cosmic bullet is heading our way, one that operates on principles of physics we can't even begin to comprehend, let alone counter? Another more biological fear emerged from this line of thinking. Perhaps the danger wasn't in its physics, but its biology. We imagine extraterrestrial life as intelligent, perhaps even technological, but the universe is vastly more likely to produce microbial life, and an interstellar wanderer like 3I, Atlas, would be the perfect vessel for it. For billions of years, it could have been tumbling through the void, a sterile, frozen arc, but as it approached our sun, its surface would warm. Dormant alien microorganisms evolved in a completely different biosphere could reactivate if data suggested that this object was shedding material, seeding its orbital path with a biological payload for which Earth's life has absolutely no defense. The response would be swift and silent. It would be a planetary quarantine enacted in secret. The global astrobiological community has protocols for this, detailed plans for containing a potential extraterrestrial contagion. And step one of every single one of those plans is informational control. You cannot risk panic. You cannot risk rogue actors trying to capture a sample. You must simply and quietly erase it from view, track it with every resource you have, and pray that its trajectory takes it far, far away from our fragile blue world. The blur in this scenario is not a wall. It is a biohazard sign, a quarantine seal placed over a potential pandemic of truly cosmic proportions. It's a paternalistic act of censorship undertaken by authorities who believe they are protecting us from a truth we are not equipped to handle, a truth that could cause the collapse of civilization not with a bang, but with a cough. This idea forces us to confront a chilling ethical dilemma. Do we have the right to know if the world is ending? Do we have a right to the data that proves our own extinction is a statistical probability? The authorities who would make such a decision would justify it as the only responsible choice. They would see themselves not as censors, but as guardians shielding humanity from a psychological collapse from which it might never recover. They would argue that some knowledge is too heavy a burden for the public mind to bear, and as we stare at that blank space in the sky, we are forced to wonder if they might be right. We are forced to ask ourselves if we truly want the unvarnished, terrifying truth of the cosmos, or if we prefer the comforting, curated reality we are given. That digital smudge represents the line between security and freedom, between protection and ignorance. And the very existence of the blur suggests that someone, somewhere, has already made that choice for us. They have weighed the consequences and decided that what lies behind that curtain is a truth we must be spared, an apocalypse we are better off not seeing coming. Yet it was the third theory, the one whispered at first, and then shouted from the fringes, that truly captured the global imagination. It was the theory that 3I, Atlas, was neither a weapon nor a plague, but a messenger, a probe. A piece of technology, intelligently designed and guided, sent from another star system. This was the modern fulfillment of a myth we have been telling ourselves for centuries, the ultimate validation of our hope that we are not alone. And it is this possibility, more than any other, that provides a compelling, almost irresistible motive for absolute secrecy. The discovery of an alien artifact, even a defunct one, would be the single most transformative event in human history. It would shatter every religion, every political structure, every philosophical understanding of our place in the universe. It would be a revelation on a species-wide level, an intellectual fire that could either illuminate our future or burn our civilization to the ground. An authority facing this reality would not see a moment of wondrous discovery. They would see a moment of maximum global instability. Here, the precedent of Oumuamua, our first confirmed interstellar visitor, becomes crucial. Oumuamua was a tantalizing mystery. Its strange, elongated shape, its lack of a cometary tail, and its slight but distinct non-gravitational acceleration led some of the world's most respected astronomers to seriously entertain the hypothesis that it was an artificial object. But it was moving too fast, spotted too late. It was a fleeting glimpse, a cosmic question mark that swept past us and disappeared back into the darkness. 3I, Atlas, however, was different. Its trajectory was slower, its detection earlier. It was our second chance. It was the one we could perhaps study in detail. Ufologists and independent researchers argue that this is precisely what happened. They contend that advanced tracking systems, perhaps the very same ones used to monitor military assets in orbit, got a much closer look at 3I, Atlas. And what they saw was so unambiguously artificial, so paradigm-shattering, that the order came down from the highest levels: shut it down. Erase the public data. Classify everything. The blur on Google Sky wasn't just hiding a dot of light, it was hiding the answer to the oldest question we have ever asked. A prominent ufologist, a man long dismissed by the academic establishment, spoke with a kind of vindicated fury. To him, the blur was the smoking gun he had been searching for his entire life. He believed the object was likely a Bracewell probe, a type of autonomous robotic interstellar messenger designed to find emerging technological civilizations, observe them, and perhaps even make contact. He pointed to alleged but unverified radio signal intercepts and radar data leaks, fragments of information that painted a picture of an object maneuvering, changing its orientation, perhaps even decelerating as it approached our solar system. He argued that its fragmentation, officially reported by mainstream astronomy as the natural decay of a fragile comet, was a lie. He proposed it was a deliberate act, the probe releasing smaller subprobes into our solar system, or perhaps even a self-destruct sequence to prevent its capture. The official story was a fabrication, the blur a confession. It was an admission through action that something had arrived which could not be explained by the gentle, predictable laws of celestial mechanics. It was the arrival of another mind, and the powerful had decided that we, the public, were not ready to meet it. Even more sober voices from the scientific community acknowledged the profound gravity of such a scenario. An astrobiologist from a major university, careful not to endorse any specific theory, explained the stakes. If we were to confirm a technosignature, an undeniable sign of alien technology, the established protocols are complex and heavily debated. But they all begin with verification, and that verification process would by necessity be conducted in secret. The potential for misinterpretation, for public hysteria, for military escalation among rival nations hoping to seize the technology is simply too great. The discovery wouldn't be announced in a triumphant press conference. It would be locked down, studied by a small, isolated group of experts under military guard, its existence becoming the most significant state secret in human history. The team in charge of this secret would face an impossible dilemma. Releasing the information could unify humanity, or it could trigger wars for the alien technology. It could elevate our consciousness, or it could lead to the collapse of social order as established beliefs crumble. Faced with that gamble, the safest, most conservative option is always silence. It's control. The blur becomes the first act of a new kind of governance, the governance of a truth so immense it could break the world. A former high-level member of the intelligence community offered the final chilling piece of this puzzle. He described what he called the calculus of contact. From a national security perspective, an alien probe is not a wonder. It is an unknown variable of infinite potential threat. He explained that the first questions would not be, are they friendly, or what can they teach us? The first questions would be, what are its capabilities? Can it be weaponized? Can it be reverse engineered? And most importantly, who can we allow to know about it? The immediate response would be to treat it as a foreign intelligence asset. You secure it, you deny its existence, and you exploit it. The idea of sharing this discovery with the world, or even with other nations, would be seen as strategically suicidal. The nation that controls the first contact that holds the keys to alien technology could potentially hold the keys to the entire planet. And so the greatest discovery in the history of science becomes the greatest secret in the history of espionage. That blank space on the star map is not just a missing object, it is a prize. It is the beginning of a new silent arms race, a competition to unlock the secrets of 3I, Atlas, before anyone else does. The mystery of the blur opens a Pandora's box of human fallibility, showing us that even at the precipice of cosmic enlightenment, our first instincts might be suspicion, secrecy, and the acquisition of power. The act of censorship then reveals a stark and uncomfortable truth not about aliens, but about ourselves. It suggests that our systems of governance are fundamentally unprepared for a universe that is more complex than we imagine, and that those in power would rather blindfold us than risk us seeing what is truly out there. This deliberate void, this manufactured emptiness in our sky has now become the story. It is a monument to a secret, a testament to a truth deemed too large for public consumption. And it has ignited a fire fueling a new breed of digital explorers, citizen scientists, and rogue astronomers who now refuse to accept the curated reality they have been given. They are no longer just looking for 3I, Atlas. They are now in a battle for the truth itself, convinced that somewhere in the discarded data and the hidden archives, the ghost in our machine has left a trail they are determined to find. For weeks, the global effort had felt like trying to hear a single pin drop in the middle of a planetary orchestra, a search for a ghost in a machine that was actively trying to forget it. The Data Coalition, a decentralized army of professionals and amateurs, had gathered every scrap of information that existed before the great digital redaction. They possessed pre-blur survey plates from Palomar, forgotten infrared captures from Spitzer, and even faint, noisy radio frequency maps from arrays that had been tracking quasars, but just happened to swing across that fateful patch of sky. Each piece was a single, distorted note. Alone, they were meaningless static, a chorus of cosmic noise. But the breakthrough, when it finally came, wasn't a sudden shout from the void. It was a slow, dawning realization, emerging from the painstaking process of algorithmic layering, of noise cancellation so extreme it bordered on data archaeology. A team in Helsinki specializing in thermal imaging had developed a program to stack hundreds of low-resolution heat signatures, averaging out the background radiation of the universe itself. They fed it everything, and there, in the silent dark of a Finnish winter morning, it appeared. It wasn't an image you could see with your eyes, not a photograph of a thing. It was a graph, a line of code, made manifest a story told in the language of thermodynamics. A heat signature, but this signature was utterly, fundamentally wrong. Everything in space, from a moon to a comet to a distant galaxy, cools in a predictable way. It radiates heat in a smooth, continuous curve described by elegant 19th century physics. This object did not. Its thermal decay curve was jagged, stepped, almost digital. It would cool for a period, then plateau, holding a specific temperature with impossible stability before decaying again. It was as if something inside it was periodically, methodically fighting against the cold of the void. As if a thermostat was clicking on and off 300 million miles from home. This wasn't the slow, graceful cooling of a dying ember. This was the controlled, regulated heat of a machine. The coalition cross-referenced the timestamp of every plateau on that thermal graph with the other datasets. The static from the radio arrays previously dismissed as interference suddenly snapped into focus. During each thermal plateau, a faint, whisper-thin burst of coherent microwaves was being emitted. Not a message, not a signal meant for us. It was more like exhaust. The kind of low-level, undirected energy leakage you would expect from a power system of immense complexity and efficiency, a system cycling on just long enough to maintain its core functions. This was the moment the ground gave way beneath us. We had all been operating under the assumption that 3I, Atlas, was a natural object behaving unnaturally, a comet with a strange composition, an asteroid with a bizarre outgassing pattern. We were arguing about the footnotes of geology and physics. But this data, this ghost in the machine, suggested a conclusion so profound it felt like a physical blow. The simplest explanation, the one that fit every single piece of this fractured puzzle, was that 3I, Atlas, was not a natural object at all. The orbital mechanics, which had baffled astronomers, suddenly made a terrifying kind of sense. It hadn't been tumbling. It had been correcting. The faint, almost imperceptible shifts in its trajectory attributed to outgassing were not random puffs of gas. They were precise, calculated, minuscule adjustments. This wasn't an object being pushed and pulled by the sun's gravity and radiation. This was an object navigating. It was using our sun not as a destination but as a waypoint. A gravitational anchor to execute a slingshot maneuver of staggering precision, a cosmic turn that would fling it out of our solar system and towards an entirely new destination in the interstellar dark. It was a traveler, merely passing through. The composition analyzed from the scant pre-blur spectroscopic data became the final chilling confirmation. Among the faint traces of silicates and frozen gases were spectral lines that had no business being there. Spikes in the data corresponding to isotopes of niobium and technetium elements that in these specific refined forms are not found in nature. They are manufactured. They pointed to a structure of unimaginable resilience and technological sophistication. A hull made of materials designed to withstand the erosion of interstellar dust and the bombardment of cosmic rays for millennia. A power source, likely a form of microfusion or a contained matter-antimatter reaction that could lie dormant for eons, only to cycle on for brief moments to preserve its internal systems. We were staring at the shadow of a von Neumann probe, an autonomous, self-replicating interstellar explorer, or perhaps something even more enigmatic, a Bracewell probe designed not to explore but to listen. To park itself in a star system, go silent, and passively observe the birth and evolution of life only moving on when its mission was complete or its target system went silent. Was it arriving, or was it leaving? Had it been here for 1,000 years, 1,000,000, silently watching from the frozen dark beyond Neptune, its work now concluded? Did it witness the rise of the dinosaurs, the first hominids, or had it just arrived a silent sentinel on the edge of our awareness, taking our measure before continuing its endless journey? The questions were overwhelming, but one single question now burned with the heat of a supernova. Why hide it? Why the unprecedented clumsy global act of digital censorship? The coalition, in a final flurry of collaboration, began to piece together a timeline not of the object but of the discovery itself. The initial observations of 3I, Atlas, were public, flowing into automated systems around the world, including the algorithms that power Google Sky. These systems are designed to ingest raw data from observatories and stitch it into a seamless celestial map, but they are also designed to flag anomalies. An object with a non-Keplerian orbit, a bizarre spectral signature, a heat profile that defied the laws of blackbody radiation. It would have triggered a cascade of automated alerts, not to the public but to system administrators, and from them to the scientific liaisons within the company. From there, the trail points not to a corporate decision but to a state-level one. Imagine the conversation. A quiet phone call from a 3-letter agency to a senior executive. A conversation that likely never mentioned aliens or probes. It would have been framed in the dry, sterile language of national security. An unidentified object with advanced maneuvering capabilities and an unknown energy source has been detected. Its nature is unconfirmed. Its origin is unknown. Its capabilities are undefined. Public knowledge of this object before it can be fully understood constitutes a potential threat. It could cause mass panic. It could trigger geopolitical instability, a frantic new arms race to understand and replicate the technology. The object itself might interpret widespread focused observation from our planet as a sign of detection, potentially eliciting a response we are not prepared for. Therefore, under national security provisions, its location and data must be contained, not deleted but occluded. A temporary measure, they would say, until a fuller assessment could be made. It wasn't a conspiracy born of malice. It was a quarantine born of fear. Fear of the unknown, yes, but also fear of ourselves. Fear of how we as a species would react to the single greatest discovery in human history. Google, faced with a legally binding directive from a government entity operating under the umbrella of planetary defense, had no choice. They complied. The blur was not an admission of guilt. It was an act of silent, forced cooperation. The clumsy, imperfect nature of the censorship, the fact that it only covered one platform, suddenly made sense. It was a rushed job, an emergency protocol enacted, with little planning aimed at the single largest public-facing celestial database in the world to quell immediate, widespread discovery. They weren't trying to build a perfect prison for the secret. They were just trying to lock the front door while they figured out what was happening. The coalition of independent scientists and citizen journalists had, in effect, picked the lock. They had gathered the evidence from all the open back windows and side entrances, piecing together the very truth the authorities had sought to contain. On March 12th, they published everything. A 200-page paper complete with all the raw data, the thermal graphs, the spectroscopic analysis, and the reconstructed orbital plots. It was released simultaneously on dozens of servers worldwide, a decentralized flood of information that could not be stopped. The document didn't scream aliens. It was sober, scientific, and methodical. It simply laid out the evidence step by undeniable step and concluded that 3I, Atlas, was an object of non-natural and therefore non-human origin. The paper landed in the global consciousness not like a bombshell but like a change in the laws of physics. For the first few hours there was a stunned silence. News organizations, governments, and scientific institutions scrambled to understand, to verify, to craft a response. Then the silence broke, and the world began to speak all at once. For some, it was a moment of pure, unadulterated awe. The confirmation that we are not alone, a validation of a hope humanity has whispered to the stars for its entire existence. The feeling was not of fear, but of profound, earth-shattering connection to something larger than ourselves. Our lonely little island in the cosmos suddenly had a visitor, or at least evidence that the ocean was not empty. We had found a footprint on an infinite shore. For others, it was a moment of supreme terror. The implications were too vast, the technology too advanced. An object that could navigate interstellar space with such ease represented a power so far beyond our own that it rendered our entire civilization infinitesimal. Were they peaceful? Were they hostile? Were there more? The very foundations of religion, philosophy, and national security seemed to crumble under the weight of the revelation. And for a third group, there was only angry denial. It was a hoax, a misinterpretation of the data, a grand conspiracy by the scientists themselves. They clung to the familiar, refusing to accept that the universe they thought they knew had been irrevocably altered. Google, in a brief statement, finally broke its silence. It admitted to a temporary curation of specific astronomical data in response to a request from multiple governmental space and defense agencies regarding an object whose characteristics were under active investigation. It was a corporate sidestep, a masterpiece of saying nothing while confirming everything. The blur, the central mystery that had ignited this entire firestorm, was finally explained. It was the frantic, desperate attempt of a handful of powerful people to put the genie back in the bottle, an attempt to manage the unmanageable, to control the single most uncontrollable truth imaginable. But in solving the mystery of the blur, we had unleashed a far greater one. We now knew with a certainty that chilled the blood and electrified the soul that they are out there. Or at least their technology is. We had the proof. What we didn't have was the object itself. While we were arguing, while we were searching and hiding and revealing 3I, Atlas was continuing its journey. The maneuver was complete. It had used our sun's gravity like a key in a lock, turning its trajectory and accelerating to a velocity that would ensure its escape from our system. It was already receding, a ghost fading back into the dark, growing fainter with every passing second. The blur on our screens was gone, replaced by the stark, terrifying, and exhilarating reality of what had been there. We had solved the puzzle of the censored sky. Now we were left with an infinitely larger one. We had seen the messenger, but we had no idea what its message was, where it was going, or who had sent it. We had peered through the keyhole, and now we knew there was a door. What lies on the other side, and will it ever open for us? And so, after a frantic chase across the digital cosmos, we arrive here. At the end of a breadcrumb trail made not of light but of its absence. It all began with a smudge, a tiny patch of curated darkness. A wound in the otherwise perfect tapestry of a star-filled sky served to us on our screens. A single act of digital redaction that did not create silence, but instead ignited a global roar of inquiry that echoed from university radio telescopes to amateur astronomy forums in the dead of night. The journey to understand that blur and the fleeting phantom it concealed has been a testament to our species' most defining trait, an insatiable, unyielding, and sometimes maddening curiosity. We have traversed a labyrinth of conflicting official statements, navigated a storm of online speculation, and witnessed the birth of a new kind of scientific revolution, one fought not in labs, but across the distributed network of human consciousness. Now, standing at the precipice looking back at the whirlwind, what have we truly learned? What is the ultimate truth of 3I? Atlas, the ghost in the machine, after filtering the noise, after cross-referencing the incredible work of citizen scientists with declassified data and, off-the-record admissions from sobered insiders, a coherent, if unsettling picture emerges. 3I, Atlas, the third interstellar object ever detected, was not merely a rock. The data painstakingly reassembled from independent observatories that captured it before the digital shroud fell tells a story of an object behaving under pressures unknown in our own solar system. Its trajectory was more than a simple hyperbolic arc. It was a path influenced by outgassing, yes, but of a composition that left spectrography experts deeply perplexed. The initial readings, the ones that likely triggered the automatic redaction protocols, showed spikes in elements not typically dominant in cometary comas, signatures of isotopes that hinted at an origin star system far older and far more metal-rich than our own. This was not a simple messenger from a nearby star. This was a relic, a fragment from a galactic history so ancient that its parent star may have died before our Earth had even coalesced from dust. It tumbled through the void, a time capsule carrying the elemental ghost of a long-extinct sun. Its light curve, the measure of its brightness over time, was not the gentle sine wave of a uniformly rotating body. It pulsed, it flared, it shuddered with a chaotic rhythm, suggesting its journey through the interstellar medium had been violent. It was not a pristine traveller, but a battered survivor. This object was, in the words of one astrophysicist who spoke to us anonymously, cosmically significant. A 1 in a billion visitor whose chemical makeup was a Rosetta Stone for understanding stellar evolution in a distant, ancient arm of the Milky Way. And for a few crucial hours, its existence, its very coordinates, were deliberately hidden from you. The blurring of Google Sky, we can now say with a high degree of certainty, was not a simple glitch. It was not a server error or a corrupted image file, as the first public relations statement so unconvincingly claimed. It was the result of a data-sharing intercept, a protocol that exists deep within the architecture of how astronomical data is shared between military intelligence and civil agencies. The system is automated. It acts as a digital immune response, scanning for specific threats, asteroids on a collision course with Earth, for instance, or unidentified objects passing too close to sensitive orbital assets. But it also contains flags for what is termed exotic spectral signatures. The unique metal-heavy composition of 3I Atlas, combined with its high-velocity interstellar trajectory, tripped one of these deep, rarely activated flags. For a brief period, the object was flagged not as a scientific curiosity, but as a potential non-terrestrial threat vector, a designation that automatically triggers a Level 3 information quarantine. The digital blur was not an act of malice, but an act of protocol, a cold, unthinking algorithm doing exactly what its secretive programmers had designed it to do: wall off the unknown until it could be understood by a select few. It was a form of institutional caution so profound, so deeply ingrained, that its default response was to hide, to obscure, to treat a phenomenal opportunity for universal knowledge as a secret to be kept. The system, however, was never designed for an age of ubiquitous information. It never anticipated a world where millions of eyes, both amateur and professional, were already watching. The act of concealment backfired with spectacular force. It was a clumsy analog-era reflex in a digital, interconnected world, and it created a vacuum that human nature abhorred. Into that vacuum flooded the full spectrum of the human imagination. This brings us to the second and perhaps more enduring truth revealed by this saga: the awesome, terrifying, and world-altering power of citizen science in the 21st century. We witnessed a planet-wide, decentralized research project assemble itself spontaneously. While official channels were silent, a global nervous system of inquiry came alive. Data analysts in Tokyo collaborated with amateur astronomers in rural Argentina. Software engineers in Silicon Valley wrote scripts to scrape archival data, while history buffs in Europe scoured ancient astronomical records for any hint of a similar visitor. They were agile where institutions were slow. They were passionate where bureaucracy was sterile. They refused to be placated by soothing, empty statements, and they used the very tools of the digital age, social media, cloud computing, collaborative forums, to challenge the gatekeepers of Starlight. They became a check, a balance, a force of public accountability on a cosmic scale. This was their triumph. They proved that the pursuit of knowledge is not the exclusive domain of those in ivory towers or classified bunkers. The sky, they declared through their actions, belongs to everyone. Yet we must also confront the shadow that this triumph casts. For every rigorous piece of crowdsourced analysis, a dozen wild conspiracies bloomed. The information vacuum was filled not only with brilliant insight, but with paranoid delusion. The blur was seen as proof of alien motherships, of secret government weapons, of impending biblical prophecy. The digital tools that enabled global collaboration also became vectors for mass misinformation, spreading falsehoods at the speed of light. We saw how quickly the noble quest for truth could curdle into a witch hunt, how a lack of official transparency could breed a corrosive systemic distrust that poisoned the entire well of public discourse. The story of 3I, Atlas, is therefore a cautionary tale. It is a stark illustration of the signal-to-noise problem in our modern world. How do we as a species harness the incredible power of collective intelligence without succumbing to the siren song of collective hysteria? How do we foster healthy skepticism without letting it decay into reflexive, all-consuming cynicism? This is the tightrope we now walk, every single one of us. And this leads us to the final, most profound questions that this small, blurred-out patch of sky forces us to confront. Questions about our future, not just among the stars, but here with each other. The incident has irrevocably challenged the old narratives of control. Who has the right to edit our view of the universe? If a government or a corporation can digitally erase a star, a comet, an interstellar visitor, what else can they erase? The sky has been a source of constants for all of human history, a shared canvas upon which we have painted our myths, our gods, our scientific ambitions. But the 3I Atlas affair revealed that this canvas is no longer pristine. It is a data set, a stream of information that can be filtered, altered, and curated before it ever reaches our eyes. We are now forced to ask a question that would have seemed absurd just a decade ago. Can we still trust our own windows to the cosmos? This event was a paradigm shift. It was the moment the concept of information sovereignty leapt from the terrestrial internet and was projected onto the celestial sphere itself. We have begun a new and vital conversation about the ethics of astronomical data, about the fundamental right to unfiltered starlight. We must now demand a new covenant of transparency from the institutions we entrust with our cosmic senses, our telescopes, our probes, our sky surveys. Because if we are to face the profound discoveries that await us in the void, we must face them together as a species in the full light of day. Secrets and shadows have no place in the grand endeavor of exploration. They breed fear, and fear is the enemy of wonder. In the end, the legacy of 3I, Atlas, is not just the story of a strange interstellar rock, nor is it merely about a clumsy act of digital censorship. It is the story of how a tiny anomaly, a flicker of wrongness on a computer screen, held up a mirror to our modern world. It showed us our greatest strengths, our boundless capacity for collaboration, our deep-seated hunger for truth, our ability to self-organize and demand accountability. It also showed us our deepest flaws, our vulnerability to misinformation, our tendency toward tribalism and paranoia, our struggle to reconcile institutional authority with individual freedom. 3I, Atlas, has now fled our solar system. It is once again a solitary traveler receding into the infinite darkness, carrying its ancient secrets with it. It will likely never be seen by human eyes again, but its passage has changed us. It left a permanent mark not on the sky, but on our perception of it. From now on, when you look up at the night sky, you will see it differently. You will see the familiar constellations, the steady light of the planets, the gentle arc of the Milky Way. But you will also know that what you see is a negotiated reality, a picture that has been transmitted, processed, and delivered. You will carry the knowledge that the map is not always the territory, and you might find yourself asking the question that propelled this entire journey, the question that we must never ever stop asking. If something was hidden there in that one small patch of darkness, what else might be hiding right now in plain sight?